I want to find the positive values of p for which this series converges. So first I'm going to look at p equals 1. So when p equals 1, I have the sum n equals 2 to infinity, the natural log of n over n. I'm going to use the integral test, and I'm going to say that it's the limit equals the limit as b goes to infinity, the integral from 2 to infinity. I start at 2 because n starts at 2, of the natural log of x over x dx. If I use substitution, if u is the natural log of x, du is dx over x. So this is just a derivative of natural log. So this becomes the limit as b goes to infinity of the natural log of x squared over 2 from 2 to b. And this is to b, sorry. 2 to b. So if I plug it in, as b goes to infinity, this is going to go to infinity. So this diverges. 1p is 1. Now I'm going to look at other p. So again, I'm going to use the integral test. So I have the sum as n equals 2 to infinity of the natural log of n over n to the p. So that's the same as a limit as b goes to infinity of the integral from 2 to b of the natural log of x over x to the p dx, which equals the limit as b goes to infinity of the integral from 2 to b of x to negative p natural log of x dx. Well, to solve this, I'm going to have to use integration by parts. So I am going to set u is going to be the natural log of x. So du is dx over x, and dv is going to be x to the negative p dx. So v is going to be x to the negative p plus 1 over negative p plus 1. I'm going to rewrite this as x to the 1 minus p over 1 minus p. I'm just changing the order there. So now this whole thing is the limit as b goes to infinity of uv, which is x to the 1 minus p over 1 minus p times the natural log of x from 2 to b minus the integral from 2 to b of v du, which is x to the 1 minus p over 1 minus p times dx over x. So I get rid of one of those p's, so this becomes integral from 2 to b of I'm going to put the 1 over 1 minus p out.